Greetings, this is Mark Anderson for Kellogg Community College, and I'm going to be doing the Algebra of Functions. Going to look at some examples of putting functions together. Now, essentially there's 4 parts to each of these problems in this video here. This is A, where we're going to take f plus g, the 2 functions, and add them together. We're going to take B, we're going to subtract f and g. C is going to be to multiply f and g, and then we're going to do part D, which is dividing f and g, and we're also going to be finding the domain. So in part A, we're going to now go the function of f plus the function of g, and these are the 2 functions. But something I should talk about right before we get started is one of the ways that we can kind of safeguard ourselves with domain is we're going to look for restrictions. And so far, up to this point, we only really have 3 restrictions, and there's actually only 2 in one composition of a restriction. So here's what I ask my students. In function f or in function g, are there denominators? Are there square roots? Or square roots in the denominators? And since the answer is no to each of those questions in function f, then f can be all real numbers. And the same thing goes for g. G can be all real numbers, and we're only talking about domain. These are inputs for the variable x. So this can be anything from negative infinity to positive infinity on x, and so far here. This quadratic and linear function have no restrictions. So we're going to add these together. So I'm going to take my f of x equation and add it to my g of x equation, and then see what I can do. Now, these parentheses are stylistic because I'm just going to try to collect like terms here, and I would have no other thing with the x squared. The x is going to be also by itself, and then minus 25, and the minus 5 is going to be negative 30. The domain is going to be all real numbers because we don't actually, in the addition of these 2 functions, don't create new denominators or square roots in the denominators. All right, so for part B, we're going to subtract these 2. And now where the parentheses were stylistic in the problem above, this is actually more important because now you can see that since I have to subtract this binomial, I'm going to be subtracting these 2 terms of them, which means I'm going to have negative x plus 5, not negative x minus 5, because you're subtracting the whole binomial. So when I collect like terms, I should have x squared minus x minus 20. And the domain is going to be real again. Now, I'm not using set or interval notation here. I'm just doing a quick just writing down what the domain is because my main focus is for you to focus on the domain. So when I add or subtract these functions, I don't create new denominators or square roots in the denominators. Now I'm going to multiply f and g, or f times g. So this is going to be where the parentheses no longer are stylistic but are very functional for my FOIL. So x squared times x, this gives me x cubed. And then x squared times negative 5 is negative 5x. Let me put a little tick mark in there. Okay, negative 25 times x is negative 25x. Oh, that was squared. Oh no, hold on, let's go back again. X squared times x is x cubed. X squared times negative 5 is negative 5x squared. Haha, caught my mistake. Then negative 25 times x is negative 25x, and then negative 25 times negative 5 is plus 125, that domain of all real numbers. D is where we take f and divide it by g. Now, so far, what you've seen is that the addition, subtraction, and multiplication of real functions give you real functions. But now we're going to look at what happens when we have f divided by g. At the very start of the problem, we have x squared minus 25, and the denominator is x minus 5. Now we have a restriction on the domain, because now we have a denominator. And we do this now because, even though we want to make sure we catch it before we do any simplification. So our domain definitely cannot have 5. And it can't have 5 because since we have a denominator, the denominator cannot be equal to 0. So our x minus 5 cannot be 0. Solve for x by adding 5 to both sides, so x cannot be equal to positive 5. So that's where we get this. But there is some simplification we can do. Through the power of factoring, we can take the difference of squares in the numerator and break that down into x plus 5 and x minus 5 binomials. This x minus 5 binomial in the denominator, stylistically written with the parentheses, can simplify with the or as you would say, cancel, but it would simplify with the binomial above it. So this divided by this is 1, which gives me just x plus 5. So here, the danger is that, well, my answer doesn't have a denominator. Yeah, but the composition did. Like this way of writing this over this, which this way of writing it, it now creates a denominator. We have to identify any kind of restrictions on the domain at any part of the problem, even though if the ending did in fact kind of get fixed. So now we're going to move down to the next problem, where we are going to do our ABCD, and we're going to first of all check to see if there's any restrictions, which there's not. This parabola and this parabola have no restrictions because there are no square roots. There are no denominators, and there's no square roots in the denominators. So what we have here is two real numbers. All right, so now what we have is we have our f plus g, which is part A. So let's add the two, and we're going to use parentheses to be stylistic, x squared minus 1 plus x squared plus 2x plus 1. And essentially there are no other things to do other than combine like terms. So we have 2x squareds here, so that's 2x squared. We have a plus 2x, and then we have a minus 1 and a plus 1, so yep. That makes 0. So there is my answer, and my domain is real, because adding, subtracting, and multiplying does not add new restrictions to the domain. So let's go to my B. I'm going to subtract the 2. Now in subtracting the 2, this is important because what this is going to create is this is going to create a new set of negatives here, because I'm going to have to subtract this entire trinomial. So this is negative x squared, this is negative 2x, and this is minus 1. So now we have x squared minus x squared, which is 0x squared, or nothing. You can say it cancels, but it really does simplify. Now in terms of my powers of x, I just have a negative 2x, and now I have a minus 1, and then another minus 1, so that's minus 2, and the domain is real. So there's that. By the way, I should also point out, if you're watching this video and you're using an older worksheet of mine, please make sure that you, whoa, these are different than my worksheet. Yeah, I do sometimes change the worksheet, and that's going to be more evident as this goes on. So if you're watching this the first time and you have an older worksheet, please modify it to look like this video here instead of what's on your worksheet. All right, so then we're going to go f times g, and f times g is going to be to FOIL, but it's not quite FOIL because it's going to have a binomial and a trinomial. So what we'll do is create this kind of double rainbow. We're going to have this x squared times x squared, which is going to give me x to the 4th. We're going to have x squared times 2x, which is going to be giving me 2x cubed, and then x squared times 1, which is just x squared. Then underneath here, we're going to have a negative x squared, so there's my negative x squared. Ooh, that's nice simplification. Negative x times, or negative 1 times this is negative 2x, and negative 1 times that is negative 1. So that makes a 0. So my final multiplication of this is going to be x to the 4th plus 2x cubes, no x squareds, minus 2x minus 1, and the domain is real again, because multiplying and subtracting and adding does not add any new restrictions to the problem itself. But now here we have a situation where we have x squared. When we do our f divided by g, we have x squared minus 1 divided by x squared plus 2x plus 1. Well, now we have a denominator. And if I did my factoring in the numerator and the denominator, my numerator would be x minus 1, x plus 1, and my denominator would be x plus 1, x plus 1. And that's because the two numbers that multiply to make 1 and add to make 2 are 1 and 1. So my restriction on the domain is only negative 1, because your denominator is the only one you're looking at. Some people look at the numerator and say, well, my numerator can't be 0. No, and of course it can. Your numerator can totally be 0. It's just your denominator can't be 0 because we can't divide by 0, and we made a video covering that. So here we have just some simple simplification, x minus 1, x plus 1, and the domain restriction is still there, and it will always be there, because no matter if everything and anything gets canceled out, or simplifies to 1 over 1 or something like this, you're still going to have to look back to the original part of the problem where you created the denominator in that. piece. So for our final part of this problem here, problem number 3, the biggest push, or the biggest question that most people will have is determining the domain of g of x. So let's first of all just take a sidebar and say that this is absolutely real. But this is a problem. This is not real. And the reason why it is not real is because it has the square root of 9 minus x, so it has a square root. And we do have restrictions on square roots. Square roots have to be greater than or equal to 0. And they have to be greater than or equal to 0 because they can't be negative, because that would create imaginary numbers. So the square root can absolutely be 0, but the square root can't be negative. So what we're going to do is take the guts of the problem, the 9 minus x squared, and set that greater than or equal to 0. And we're going to solve for x. Please note, if you're using an older worksheet, that this new worksheet has flipped f and g for the purposes of the example I'm about to give. So I'm going to subtract 9 to both sides, and this gives me negative x squared is greater than or equal to negative 9. Divide both sides by negative 1, and so now I have x squared is less than or equal to positive 9. Now, here's the real fun part. To get to the next step, I'm going to have to take the square root of both sides. But in doing so, I have a plus minus to deal with on the 9. So now I have x is less than or equal to plus or minus 3. Now, this brings up two situations. In the situation of the plus, it is x less than or equal to 3. But in the situation of the minus, x is greater than or equal to negative 3, because the plus and minus treats it like a dividing by negative, and you have to flip the symbol. In fact, I'd like you to investigate typing in the equation into your calculator, y sub 1 is equal to 9 minus x squared, and what you get is you get a half circle between negative 3 and 3, and everywhere else on the calculator's table you get an error. So x only exists between negative 3 and 3. So a big kind of a question that I got when students encountered this in an earlier section is like, I'm not sure how to have less than or equal to make this, but it's because of the negative path. The negative path flips the symbol. And so if you're remembering from your Math 101 or some of your earlier level classes, your beginning algebras and such, you do flip the symbol when you multiply or divide by a negative. And now in this case, taking the square root has you flip the symbol for the negative. Well, so here's my domain. My domain for this problem is going to be x is between negative 3 and 3. And oh my goodness, there's another situation where it's like, but couldn't I just write this down? Couldn't I just write down this and this? Isn't that a possibility? Because it's the union of these two groups between here and here. And okay, I'm going to have to be a little bit of a stickler. X is between these two, so x is greater than or equal to negative 3, and x is less than 3. So yeah, you should write it this way. I mean, I understand that you feel that this is, well, this is the same and it's equivalent. Yeah, but in terms of math grammar, this is a better way to write it rather than this. So welcome to set notation, everybody. X is knocking on the door where x is between negative 3 and 3. So this whole problem, even before we started to do parts A, B, and C, and D, even before we started that, this has been all about creating the domain parameters. Because actually, since this problem is so complicated, this f plus g just ends up being 3 plus x plus the square root of 9 minus x squared. There's actually nothing more to do. But the domain, because of this square root, is going to be between negative 3 and 3. F minus g, which is going to have this 3 minus x minus this whole thing, so minus this 9 minus x squared, well, that's, again, going to have the same domain, like so. And if we go f times g, and again, with or without parentheses is stylistic, there's something you could do here. I think it's kind of an interesting, x squared, and it's going to be a square root there. Sorry about that. A little sloppiness there with my pen. This is kind of a stylistic thing. If you can do a little distribution here and have 3 square root of 9 minus x squared, and then minus x square root of 9 minus x squared. But you might actually have some professors who say, oh, that's just unnecessary. But that's one way you can expand it. The domain is still, though, negative 3 is less than or equal to x, which is less than or equal to 3. So you've noticed now, for two problems, that adding, subtracting, and multiplying does not add new restrictions to the domain. But now we have f divided by g. And now we have 3 plus x divided by the square root of 9 minus x. Okay, so x squared, sorry. Now I will say that we never leave square roots in the denominator, but we will kind of tackle this at a higher level. Our trig and pre-calc would take care of the square root. We're not going to, but just leaving it like this, our domain is no longer this negative 3 is less than or equal to x, which is less than or equal to 3. Now we have x between negative 3 and 3. Do you see the difference? Do you see the subtle difference? Oh, the subtle difference is that x can no longer be negative 3 or 3, because if I do that, we get division of 0, because plugging a 3 or negative 3 in for x, we get 9 minus 9, which is 0. The square root of 0 is 0, and we can't divide by 0. So the division of two functions will most certainly create a new conflict in terms of domain if there's a variable. And yeah, in this case, there was a variable. It was part of this square root. Now the square root's in the denominator, and square roots in the denominator cannot be 0 or negative. Notice I didn't say just negative. They can't be 0 or negative because theoretically, I mean not theoretically, but due to definition, 0 is neither positive nor negative. So you could still play the 9 minus x squared is greater than 0, and you would see that we would get down to the point where we would have our little split here again, and we'd have x is less than 3, and we'd have x is greater than or equal to 3. And so the and here, this intersection of these two groups, is going to give us this set notation here for this, which isn't written in proper set notation, but I just did a little shorthand so we would just focus on what's important, which is declaring the domain. Well, thank you for taking this pretty rough ride on part 1 of the Algebra of Functions video. Part 2 will get into plugging g into f and f into g, true compositions of functions and evaluations of them. So, wow, thank you very much for watching, and I will see you in part 2 of the Algebra of Functions video. Thank you.